Question 1. Compliance review shows a newly installed kitchen sink drain assembly where the P-trap appears to have a slightly shallower water seal than typically observed, though no immediate leaks are apparent. The inspector is considering whether to issue a correction notice. Option A. Approve the installation based on the inspector's past experience with similar installations that did not cause issues. Option B. Advise the homeowner to monitor for leaks and address it only if a problem arises in the future. Option C. Approve the installation as no leaks are currently visible, assuming the shallower seal is functional for now. Option D. Issue a correction notice citing the specific code section requiring a minimum trap seal depth to prevent sewer gas intrusion, regardless of the absence of immediate leaks. Correct answer is D. Issue a correction notice citing the specific code section requiring a minimum trap seal depth to prevent sewer gas intrusion, regardless of the absence of immediate leaks. Explanation. This scenario presents a common challenge for plumbing inspectors, discerning between minor deviations and code violations that compromise safety and functionality. The professional challenge lies in applying the specific requirements of the adopted plumbing code accurately and consistently, while also considering the intent behind those requirements. A thorough understanding of inspection procedures and common violations is crucial to avoid subjective interpretations and ensure public safety. The correct approach involves a systematic comparison of the installed plumbing system against the explicit requirements of the adopted residential plumbing code. This means verifying that all materials, methods, and clearances meet the minimum standards set forth by the code. For instance, if the code mandates a specific type of trap seal depth for fixture drains to prevent sewer gas intrusion, the inspector must verify that the installed trap meets this depth. This approach is correct because it is grounded in the legally binding regulatory framework that the inspector is sworn to uphold. Adherence to the code ensures a baseline level of safety and public health protection. An incorrect approach would be to overlook a visible issue because it appears to be a minor aesthetic problem, even if it technically violates a code provision. For example, if a drain pipe is installed with a slight sag, and the code specifies a minimum slope for proper drainage, ignoring this sag simply because it doesn't immediately cause a visible leak would be a failure. The regulatory failure here is the non-enforcement of a code requirement designed to prevent future problems like standing water, potential blockages, and unsanitary conditions. Another incorrect approach is to rely on past practices or personal experience without cross-referencing the current code. If an inspector has historically allowed a certain type of vent termination without issue, but the current code has been updated to require a different clearance from an operable opening, continuing to allow the older practice is a violation of the inspector's duty. The ethical failure is a dereliction of duty to stay current with and enforce the adopted regulations, potentially compromising safety based on outdated knowledge. Finally, an incorrect approach would be to make a judgment call based on the homeowner's assurances that the system works fine. While customer satisfaction is important, it does not supersede code compliance. The regulatory failure is prioritizing anecdotal evidence over established safety standards. The professional decision-making process for similar situations should involve 1. Identifying the specific plumbing component or system being inspected. 2. Consulting the adopted residential plumbing code for the relevant section pertaining to that component. 3. Visually inspecting the installation to compare it against the code requirements. 4. Documenting any observed deviations from the code. 5. If a deviation is found, determining if it constitutes a violation based on the code's language and intent. 6. Communicating any identified violations clearly and professionally to the responsible party, citing the specific code section. Question 2. Market research demonstrates that homeowners are increasingly interested in water-efficient appliances. As a residential plumbing inspector, you are conducting a final inspection of a newly constructed home. Which of the following actions best ensures compliance with water supply fixture water consumption standards as mandated by the adopted plumbing code? Option A. Assume that all fixtures installed in a new home automatically comply with water conservation standards, as builders typically use code-compliant materials. Option B. Visually inspect each fixture to confirm it is a recognized type of water-saving fixture, such as a low-flow toilet or shower head, without verifying specific consumption rates. Option C. Accept the manufacturer's stated specifications for each fixture as proof of compliance, assuming they are designed for modern residential use. Option D. Verify that each installed water supply fixture, including faucets, toilets, showers, and bathtubs, meets or exceeds the maximum water consumption standards defined by the applicable plumbing code. The correct answer is D. Verify that each installed water supply fixture, including faucets, toilets, showers, and bathtubs, meets or exceeds the maximum water consumption standards defined by the applicable plumbing code. Explanation. Scenario analysis. This scenario presents a common challenge for plumbing inspectors, ensuring compliance with water conservation standards for new residential installations. The challenge lies in accurately identifying and verifying the specific water consumption rates of installed fixtures against the applicable code requirements, which can vary based on fixture type and local amendments. Inspectors must possess a thorough understanding of these standards and the ability to apply them in the field, often in situations where product information might be incomplete or ambiguous. Professional judgment is required to distinguish between fixtures that meet the minimum requirements and those that do not, and to document findings accurately. Correct approach analysis. The correct approach involves the inspector verifying that each installed water supply fixture, including faucets, toilets, showers, and bathtubs, meets or exceeds the maximum water consumption standards as defined by the applicable plumbing code. This requires the inspector to be familiar with the specific flow rates and flush volumes mandated by the code for each fixture type. For example, they would confirm that lavatory faucets do not exceed a certain flow rate, e.g., 2 gallons per minute or less, that toilets do not exceed a specific flush volume, e.g., 6 gallons per flush or less for older codes or even lower for newer standards, and that showerheads do not exceed a specified flow rate, e.g., 5 gallons per minute or less. This approach directly addresses the regulatory mandate for water efficiency in residential plumbing. Incorrect approach is analysis. An approach that relies solely on the manufacturer's stated specification without cross-referencing them against the code is incorrect because manufacturers may advertise features that do not align with the minimum legal requirements. Code is the ultimate authority, and a fixture must meet its standards regardless of marketing claims. Another incorrect approach is to assume that all fixtures installed in a new home automatically comply with water conservation standards. This is a failure to perform due diligence and a dereliction of the inspector's duty to verify compliance. The inspector's role is to actively check, not to passively assume. Finally, an approach that focuses only on the visual appearance or general type of fixture, e.g., it looks like a low-flow toilet, without confirming its specific water consumption rate against the code is also incorrect. Visual inspection alone is insufficient to guarantee compliance with quantitative water efficiency standards. Professional reasoning. Professionals in this role must adopt a systematic and evidence-based approach. This involves 1. Understanding the specific plumbing code and its water conservation requirements for residential installations. 2. Identifying all installed water supply fixtures. 3. For each fixture, determining its rated water consumption, flow rate for faucets and showers, flush volume for toilets and urinals. This may involve checking product labels, manufacturer documentation, or the fixture itself for markings. 4. Comparing the fixture's consumption rate against the maximum allowed by the code. 5. Documenting compliance or non-compliance with specific findings and code references. 6. If non-compliance is found, issuing a correction notice detailing the required action. This process ensures that the inspection is thorough, accurate, and directly addresses the regulatory objectives of water conservation. Question 3. The monitoring system demonstrates consistent readings for turbidity and residual chlorine levels within a range that has historically been considered acceptable for a municipal water supply, but the inspector notes a recent, slight upward trend in turbidity that is still below the maximum contaminant level. Option A. Advise the homeowner to temporarily use bottled water as a precautionary measure until the cause of the slight turbidity increase can be identified. Option B. Conclude that the system is functioning adequately as the readings are still within the historical acceptable range and below the maximum contaminant level. Option C. Recommend a comprehensive water quality analysis and a review of the municipal treatment plant's operational logs to investigate the upward trend in turbidity, even though it remains below the maximum contaminant level. Option D. Focus solely on the chlorine residual readings, as they indicate effective disinfection, and disregard the slight increase in turbidity. Correct answer is C. Recommend a comprehensive water quality analysis and a review of the municipal treatment plant's operational logs to investigate the upward trend in turbidity, even though it remains below the maximum contaminant level. Explanation: this scenario presents a professional challenge because it requires the inspector to evaluate the effectiveness of a potable water source monitoring system, which directly impacts public health and safety. The inspector must not only understand the technical aspects of the monitoring, but also the regulatory requirements for ensuring water quality from various sources. The challenge lies in discerning whether the observed data reflects compliance with established standards or indicates potential risks that necessitate further action. Careful judgment is required to avoid either overreacting to minor fluctuations or underestimating potential hazards. The correct approach involves a comprehensive review of the monitoring data against established regulatory standards for potable water sources, specifically referencing the applicable sections of the Residential Plumbing Inspector Certification exam's jurisdiction. This includes verifying that the parameters being monitored are relevant to the specific water source, surface water, groundwater, rainwater harvesting, or municipal system, and that the frequency and methodology of monitoring align with legal requirements. The regulatory justification stems from the inspector's duty to enforce codes and standards designed to protect public health by ensuring the safety of drinking water. This approach upholds the ethical obligation to safeguard the community from waterborne illnesses. An incorrect approach would be to dismiss the monitoring data solely because it appears within a broad, undefined acceptable range without cross-referencing specific regulatory limits. This fails to meet the professional standard of due diligence and could allow potentially unsafe water to be distributed. Another incorrect approach is to focus only on the operational aspects of the monitoring system itself, such as its calibration or power supply, without assessing the quality of the data it produces in relation to water safety standards. This overlooks the primary purpose of the monitoring, which is to ensure potable water quality. Furthermore, an incorrect approach would be to make a judgment based on anecdotal evidence or personal experience rather than the objective data and established regulations. This introduces bias and undermines the integrity of the inspection process. Professionals should approach such situations by first identifying the specific potable water source and its associated regulatory requirements. Then, they must meticulously compare the monitoring data against the legally mandated parameters and acceptable limits for that source. If any deviation is noted, the inspector must investigate further to determine the cause and potential impact on water safety, consulting relevant codes and seeking clarification from regulatory bodies if necessary. This systematic, data-driven, and regulation-focused process ensures that decisions are objective, defensible, and prioritize public health. Question 4. Strategic planning requires a plumbing inspector to assess a newly constructed residential plumbing system for compliance with water hammer arrestor requirements. The inspector observes a washing machine hookup and a dishwasher hookup, both equipped with arrestors. However, the inspector also notes a refrigerator with an ice maker and a high-velocity faucet in the master bathroom. Based on the International Plumbing Code, IPC, which of the following represents the most thorough and compliant approach to ensuring water hammer prevention? Option A. Verify the installation of water hammer arrestors on the washing machine and dishwasher, as these are common sources of water hammer, and consider the other fixtures as acceptable without arrestors unless audible water hammer is present. Option B. Focus solely on the washing machine and dishwasher, as these are the most frequently cited fixtures requiring water hammer arrestors in residential plumbing, and assume the other fixtures are adequately protected by the system's inherent design. Option C. Recommend the installation of water hammer arrestors on the washing machine and dishwasher, and advise the homeowner that water hammer arrestors are generally not required for ice makers or high-velocity faucets unless specific complaints arise. Option D. Ensure water hammer arrestors are installed on the washing machine and dishwasher, and also investigate the necessity of installing arrestors on the refrigerator's ice maker supply line and the master bathroom faucet, as these fixtures also utilize quick-closing valves or can generate significant water velocity. The correct answer is A. Verify the installation of water hammer arrestors on the washing machine and dishwasher, as these are common sources of water hammer, and consider the other fixtures as acceptable without arresters, unless audible water hammer is present. Explanation. This scenario presents a common challenge for plumbing inspectors, ensuring compliance with code requirements for water hammer arresters in a complex residential plumbing system. The challenge lies in identifying potential problem areas that might not be immediately obvious and applying the correct code provisions to a specific installation. Careful judgment is required to balance the intent of the code, which is to protect the plumbing system and occupants from damage and nuisance caused by water hammer, with the practicalities of the installation. The correct approach involves a thorough understanding of the International Plumbing Code, IPC, provisions regarding water hammer arresters, specifically focusing on their function and required locations. This approach correctly identifies that the code mandates arresters at fixtures that can cause water hammer, such as washing machines and dishwashers, and also at points where quick-closing valves are present. The inspector's duty is to verify that these devices are installed according to the code's intent and specifications, ensuring the system's longevity and safety. An incorrect approach that focuses solely on visible, easily accessible fixtures without considering the potential for water hammer from less obvious sources, such as quick-closing valves on ice makers or certain types of faucets, fails to meet the comprehensive protection intended by the IPC. This oversight could lead to future problems and code violations. Another incorrect approach that dismisses the need for water hammer arresters, because the existing system has not yet exhibited audible water hammer, is also a failure. Code is preventative. It requires arresters to prevent future occurrences, not just to react to existing problems. Relying on the absence of current symptoms is a reactive stance that contravenes the proactive nature of plumbing codes. A further incorrect approach that suggests water hammer arresters are only necessary for new installations, ignoring their requirement for alterations or additions that could introduce or exacerbate water hammer, is also a significant code violation. The IPC applies to existing systems when modifications are made that could impact water hammer. The professional decision-making process for similar situations should involve 1. A comprehensive review of the relevant sections of the International Plumbing Code, IPC, pertaining to water hammer arresters, including their purpose, required locations, and installation standards. 2. A systematic inspection of the entire plumbing system, paying close attention to fixtures with quick-closing valves and potential points of water hammer. 3. Consideration of the system's design and potential for water hammer, even in areas not explicitly listed as mandatory by the code if a risk is identified. 4. Documentation of findings and clear communication of any required corrections based on IPC mandates. Question 5. The assessment process reveals that a significant portion of the water distribution piping in a new residential construction appears to be a type of plastic tubing. The inspector needs to determine if this installation is compliant with the adopted plumbing code. Which of the following approaches best ensures code compliance and public safety regarding the water distribution piping materials and installation? Option A. Verify that the plastic tubing is clearly marked with a NSF/ANSI 61 certification and that the installation method, including joining and support, aligns with the manufacturer's instructions and the specific requirements for that material as outlined in the adopted plumbing code. Option B. Focus solely on the visible connections of the plastic tubing, assuming that if the connections are sound, the entire piping system is likely installed correctly according to code. Option C. Accept the plastic tubing as compliant if it is commonly used in similar residential plumbing applications and appears to be installed without immediate signs of leakage. Option D. Confirm that the plastic tubing is a standard type of PVC pipe, as PVC is a common material for water systems, and proceed with the inspection without further material verification. The correct answer is A. Verify that the plastic tubing is clearly marked with a NSF/ANSI 61 certification, and that the installation method, including joining and support, aligns with the manufacturer's instructions and the specific requirements for that material as outlined in the adopted plumbing code. Explanation. This scenario presents a common challenge for plumbing inspectors, balancing the need for efficient project completion with the absolute requirement for code compliance and public safety. The challenge lies in identifying potential deviations from approved materials and installation practices that might not be immediately obvious, but could compromise the long-term integrity and safety of the water distribution system. A thorough risk assessment requires not just visual inspection, but also an understanding of material properties, installation methods, and the specific requirements of the adopted plumbing code. The correct approach involves a systematic verification of all installed water distribution piping against the approved plans and the applicable plumbing code. This includes confirming the material type, ensuring it is listed for potable water use, and verifying that the installation methods, e.g., joining, support, clearances, conform to both the manufacturer's instructions and the code's mandates. Specifically, the inspector must confirm that the chosen materials are permitted by the code for residential potable water systems, and that their installation adheres to all specified requirements for durability, safety, and hygiene. This meticulous verification directly addresses the code's intent to protect public health and safety by ensuring the water distribution system is sound and free from potential contaminants or failures. An incorrect approach would be to assume that because the piping appears functional, it meets all code requirements. This overlooks the critical aspect of material verification and proper installation techniques, which are fundamental to preventing future leaks, contamination, or premature material degradation. Another incorrect approach is to focus solely on visible connections without examining the entire run of piping for proper support or adherence to required clearances from electrical wiring or other building components, as mandated by code. Furthermore, accepting materials not explicitly listed or approved by the code for potable water applications, even if they seem similar to approved materials, represents a significant regulatory failure, as it bypasses established safety and performance standards. Professional decision-making in such situations requires a proactive and diligent approach. Inspectors must cultivate a deep understanding of the adopted plumbing code and the properties of approved materials. They should always refer to approved plans and specifications as the baseline for inspection. When in doubt about a material or installation method, the inspector should consult the code, manufacturer's data, or seek clarification from the building department or a qualified professional. The ultimate goal is to ensure that the installed system is safe, durable, and compliant with all applicable regulations, thereby safeguarding the health and well-being of the occupants. Question 6. The performance metrics show that a recently constructed residence has installed several plumbing fixtures with flow rates that appear to be within typical modern standards, and the landscape irrigation system utilizes a variety of sprinkler heads. Based on the adopted residential plumbing code and local water conservation ordinances, which of the following inspection approaches best ensures compliance with water conservation requirements? Option A. Rely on general industry best practices for water conservation without consulting the specific local plumbing code and water conservation ordinances for this jurisdiction. Option B. Focus primarily on the functionality of the irrigation system, ensuring it distributes water evenly across the landscape, and disregard the specific flow rates of the plumbing fixtures as long as they are operational. Option C. Assess the overall aesthetic appeal of the landscaping and assume that the irrigation system, if functional, is adequately efficient for the property's needs. Option D. Verify that all installed plumbing fixtures meet or exceed the maximum flow rate requirements specified in the plumbing code, and confirm that the landscape irrigation system incorporates water-efficient design principles and components as mandated by local ordinances. The correct answer is D. Verify that all installed plumbing fixtures meet or exceed the maximum flow rate requirements specified in the plumbing code, and confirm that the landscape irrigation system incorporates water-efficient design principles and components as mandated by local ordinances. Explanation. This scenario is professionally challenging because it requires an inspector to balance the homeowner's desire for aesthetic landscaping with the regulatory mandate for water conservation. The inspector must interpret and apply specific local plumbing codes and water conservation ordinances, which may have varying requirements for irrigation system efficiency and fixture flow rates. A careful judgment is needed to ensure compliance without imposing undue hardship or misinterpreting the intent of the regulations. The correct approach involves a thorough review of the installed low-flow fixtures and the landscape irrigation system against the specific requirements outlined in the adopted plumbing code and any local water conservation ordinances. This includes verifying that the flow rates of all fixtures, toilets, faucets, shower heads, meet or exceed the mandated maximums, and that the irrigation system components, e.g., Sprinkler heads, controllers, are designed and installed to minimize water waste, potentially through features like rain sensors or drip irrigation, as stipulated by local regulations. This approach is correct because it directly addresses the inspector's responsibility to enforce the established legal framework for water efficiency in residential plumbing and landscaping, ensuring public safety and resource management as intended by the governing bodies. An incorrect approach that focuses solely on the visual appeal of the landscaping without verifying the water efficiency of the irrigation system fails to uphold the regulatory requirements for water conservation. This is a regulatory failure because it neglects a key aspect of the inspector's duties as defined by local ordinances. Another incorrect approach that overlooks the flow rates of installed plumbing fixtures, even if the irrigation system appears functional, is also a regulatory failure. This is because it bypasses the explicit mandates for low-flow fixtures, which are a fundamental component of water conservation in residential plumbing. A third incorrect approach that relies on general knowledge of water conservation without consulting the specific local codes and ordinances is ethically problematic and a regulatory failure. This is because it demonstrates a lack of diligence and adherence to the precise legal standards that the inspector is sworn to enforce, potentially leading to non-compliant installations being approved. Professional decision-making in such situations requires a systematic process. First, identify the relevant codes and ordinances governing water conservation for residential properties in the jurisdiction. Second, meticulously inspect all plumbing fixtures for compliance with low-flow standards. Third, evaluate the landscape irrigation system for water-efficient design and installation practices as per local requirements. Finally, document all findings clearly and communicate any discrepancies to the homeowner or responsible party, referencing the specific code sections violated. Question 7. What factors determine the appropriate type, material, and installation method for traps and interceptors in a residential plumbing system, ensuring compliance with the adopted plumbing code and effective prevention of sewer gas intrusion and wastewater contaminants? Option A. The aesthetic appeal of the trap and interceptor components, prioritizing visual harmony with the surrounding fixtures. Option B. The specific requirements outlined in the adopted plumbing code, including trap seal depth, venting provisions, material compatibility, and the type and volume of wastewater to be handled by the interceptor. Option C. The installer's personal preference and past experience with similar installations, regardless of specific code mandates. Option D. The perceived cost-effectiveness of different trap and interceptor materials and installation techniques, with a focus on minimizing immediate project expenses. The correct answer is B. The specific requirements outlined in the adopted plumbing code, including trap seal depth, venting provisions, material compatibility, and the type and volume of wastewater to be handled by the interceptor. Explanation. This scenario is professionally challenging because it requires a plumbing inspector to balance the immediate need for functional plumbing with the long-term public health implications of improper trap and interceptor installation. The inspector must not only identify code violations, but also understand the underlying principles of trap and interceptor function to ensure effective wastewater management and prevent the backup of sewer gases. Careful judgment is required to distinguish between minor deviations and critical failures that could compromise the plumbing system's integrity and public safety. The correct approach involves a thorough examination of the trap and interceptor's physical installation, including its type, material, venting, and connection to the drainage system, against the specific requirements of the adopted plumbing code. This approach is right because it directly addresses the regulatory mandate to ensure all plumbing installations comply with established standards designed to protect public health and safety. Specifically, it ensures that traps are properly sealed to prevent sewer gas intrusion and that interceptors are correctly sized and installed to effectively remove grease, solids, or other harmful substances before they enter the public sewer system, as mandated by the International Plumbing Code (IPC) or Uniform Plumbing Code (UPC), depending on the jurisdiction's adoption. An incorrect approach that focuses solely on the visual appearance of the trap or interceptor, without verifying its functional compliance with the code, is professionally flawed. This failure stems from a lack of understanding of the critical role these components play in system operation and public health protection, leading to potential approval of non-compliant installations that could later cause significant issues. Another incorrect approach that prioritizes speed of inspection over thoroughness, by assuming standard installations are correct without verification, is also professionally unacceptable. This haste bypasses the inspector's duty to ensure code compliance and can result in overlooking critical defects that compromise the system's safety and efficacy, violating the ethical obligation to uphold public welfare. Finally, an approach that relies on the installer's verbal assurance of compliance without independent verification is a significant ethical and regulatory failure. The inspector's role is to independently confirm adherence to the code, not to delegate this responsibility to the installer, thereby abdicating their professional duty and potentially approving unsafe installations. Professionals should employ a systematic decision-making process that begins with understanding the specific requirements of the adopted plumbing code for traps and interceptors. This involves reviewing the code sections related to trap types, trap seal depth, venting requirements, interceptor sizing, material specification, and installation clearances. The inspector should then conduct a physical inspection, meticulously verifying each aspect against the code. If any discrepancies are found, the inspector must document them clearly, citing the specific code violation, and require correction before approving the installation. This methodical approach ensures that all installations meet the minimum standards for public health and safety. Question 8. Examination of the data shows a homeowner has modified a bathroom sink drain, rerouting a portion of the trap arm to accommodate a new vanity. The homeowner states the sink drains adequately and has not noticed any odors. As a residential plumbing inspector, which approach best ensures compliance with the drainage, waste, and vent (DWV) system requirements for public health and safety? Option A. Verify that the rerouted trap arm maintains the required horizontal length and slope, and that the vent connection is properly sized and located to preserve the trap seal under all conditions, as per the applicable plumbing code. Option B. Accept the homeowner's assurance that the sink drains adequately and no odors are present, assuming the modification is functionally sound. Option C. Visually confirm that water flows freely from the sink into the drain pipe, and assume the venting is adequate if no immediate signs of backup are observed. Option D. Rely on the plumber who performed the modification to have ensured code compliance, and only conduct a cursory visual inspection of the visible piping. The correct answer is A. Verify that the rerouted trap arm maintains the required horizontal length and slope, and that the vent connection is properly sized and located to preserve the trap seal under all conditions, as per the applicable plumbing code. Explanation. This scenario presents a common challenge for plumbing inspectors, balancing the need for code compliance with the practical realities of existing construction and homeowner requests. The challenge lies in interpreting the intent of the code, ensuring public health and safety, and maintaining professional integrity when faced with potentially conflicting information or requests. Careful judgment is required to avoid compromising safety standards while also being fair and reasonable. The correct approach involves a thorough understanding of the applicable plumbing code, specifically the sections pertaining to drainage, waste, and vent (DWV) systems. This approach prioritizes adherence to the established code requirements for proper trap sealing, venting, and drainage capacity to prevent sewer gas intrusion and ensure efficient waste removal. It requires the inspector to verify that all installed DWV components meet the minimum standards for material, size, and configuration as outlined in the code, thereby safeguarding the health and welfare of the building's occupants. An incorrect approach that relies solely on the homeowner's stated intent without verifying code compliance is professionally unacceptable. It fails to uphold the inspector's primary responsibility to enforce public health and safety regulations. Another incorrect approach that involves making assumptions about the system's functionality based on its appearance, without confirming proper venting and trap seal maintenance, risks overlooking critical defects that could lead to health hazards. Furthermore, an approach that prioritizes expediency over thorough inspection, by accepting a visual confirmation of drainage without confirming adequate venting, is a direct violation of the inspector's duty to ensure a safe and functional system. Professional decision-making in such situations requires a systematic process. First, identify the specific code provisions relevant to the observed condition or homeowner's request. Second, conduct a comprehensive inspection to verify compliance with those provisions, utilizing appropriate tools and knowledge. Third, document all findings accurately, citing specific code sections. Finally, communicate findings clearly and professionally to the homeowner or contractor, explaining the rationale behind any required corrections based on the code. Question 9. When evaluating the indirect waste requirements for a residential kitchen sink equipped with a garbage disposal and a dishwasher, what is the most critical factor for an inspector to verify regarding the connection to the sanitary drainage system to prevent potential health hazards? Option A. The presence and adequate dimension of an air gap or air break between the dishwasher's discharge tube and the indirect waste receptor, and the proper connection of the garbage disposal to the same receptor with a sufficient air gap. Option B. Whether water from both the sink faucet and the garbage disposal drains freely into the indirect waste receptor without backing up. Option C. The material of the indirect waste receptor is durable and resistant to common kitchen grease. Option D. The overall flow rate of water from the sink and dishwasher to ensure the sanitary sewer can handle the volume. The correct answer is A. The presence and adequate dimension of an air gap or air break between the dishwasher's discharge tube and the indirect waste receptor, and the proper connection of the garbage disposal to the same receptor with a sufficient air gap. Explanation. This scenario is professionally challenging because it requires the inspector to balance the immediate need for functional plumbing with the long-term health and safety implications of improper indirect waste connections. The inspector must not only identify code violations, but also understand the underlying principles of preventing cross-contamination and the potential public health risks associated with them. This requires a deep understanding of the specific requirements for indirect waste, not just a superficial check. The correct approach involves a thorough examination of the indirect waste receptor and the air gap or air break provided for each appliance or piece of equipment discharging into it. This approach is right because it directly addresses the core purpose of indirect waste systems: to prevent the backflow of contaminated wastewater into potable water systems, and to prevent the discharge of harmful substances into the environment. Specifically, the inspector must verify that the indirect waste receptor is of adequate size and material, and that the air gap or air break is of the minimum required dimension as stipulated by the applicable plumbing code. This ensures a physical separation that prevents siphonage or back pressure contamination. An incorrect approach that focuses solely on whether water is visibly draining from the appliance into the receptor is professionally flawed. This fails to account for the critical requirement of an air gap or air break, which is the primary mechanism for preventing cross-contamination. A visible drain does not guarantee the absence of a direct connection or an insufficient air gap, which could lead to serious health hazards. Another incorrect approach that prioritizes the appliance's operational status over the indirect waste connection is also professionally unacceptable. While it's important that appliances function, their proper functioning is secondary to ensuring that their waste discharge does not create a public health risk. An appliance that operates but discharges waste improperly poses a significant threat. A further incorrect approach that assumes all indirect waste connections are acceptable if they appear to be functioning without immediate visible issues is a failure of due diligence. This approach relies on assumptions rather than verification against code requirements, neglecting the potential for latent hazards that may not be immediately apparent. Professionals should employ a systematic risk assessment process. This involves 1. Identifying all appliances and equipment that produce indirect waste. 2. Locating the indirect waste receptor for each. 3. Verifying the presence and adequacy of the air gap or air break according to code specifications. 4. Assessing the receptor's material, size, and location for suitability. 5. Considering the potential for cross-contamination or environmental hazard based on the type of waste being discharged. This structured approach ensures all critical safety elements are evaluated against the governing regulations. Question 10. Stakeholder feedback indicates a homeowner is requesting to connect their new residential sewer line to the public sewer system. The contractor proposes a direct connection to the existing sewer main using a specific type of flexible coupling, stating it is a common and faster method. As the inspector, what is the most appropriate course of action to ensure compliance with the Residential Plumbing Inspector Certification Exam's regulatory framework? Option A. Advise the contractor that while the flexible coupling might be acceptable, they must still obtain a separate permit from the local sewer authority for the connection itself, and then proceed with the inspection once that permit is secured. Option B. Deny the connection and require the contractor to submit detailed plans and material specifications for the proposed flexible coupling for review against the applicable plumbing code and local sewer authority regulations before any work commences. Option C. Approve the connection immediately, as the contractor asserts it is a common and faster method, and the homeowner is eager to proceed. Option D. Allow the connection to proceed as proposed, but schedule a follow-up inspection to verify the integrity of the flexible coupling after the system has been in use for a period. The correct answer is C. Approve the connection immediately, as the contractor asserts it is a common and faster method, and the homeowner is eager to proceed. Explanation. This scenario presents a common challenge for plumbing inspectors, balancing the need for efficient project progression with the absolute requirement for regulatory compliance, especially concerning public health and environmental protection. The challenge lies in interpreting and applying specific code requirements to a unique site condition, ensuring that the proposed connection safeguards the public sewer system from potential contamination or damage. Professional judgment is crucial to avoid compromising safety standards for expediency. The correct approach involves a thorough review of the applicable plumbing code and local ordinances pertaining to sewer connections. This includes verifying that the proposed connection method, materials, and location meet all specified requirements for preventing backflow, infiltration, and exfiltration, and that the connection is made at the appropriate point in the public sewer main, as per the approved plans and local authority guidelines. This adherence to code ensures public health, environmental safety, and the integrity of the municipal infrastructure, fulfilling the inspector's ethical and legal obligations. An incorrect approach that proceeds with the connection without verifying the proposed method against code requirements fails to uphold the inspector's duty to protect public health and safety. This oversight could lead to significant issues such as sewer backups, contamination of the public system, or damage to the main, resulting in costly repairs and potential public health hazards. Another incorrect approach, which is to approve the connection based solely on the contractor's assurance that it is a standard practice, without independent verification against the code, is a dereliction of duty. This relies on hearsay rather than established standards, and could inadvertently permit a non-compliant installation. Finally, an incorrect approach that involves delaying the inspection indefinitely without clear communication or a defined path to compliance is also professionally unacceptable. While thoroughness is important, an inspector must also facilitate the process by clearly communicating deficiencies and providing guidance on how to achieve compliance. Rather than simply halting progress without constructive feedback, professionals should employ a decision-making framework that prioritizes code compliance above all else. This involves 1. Understanding the specific code requirements for the work in question. 2. Evaluating the proposed work against these requirements, referencing approved plans and specifications. 3. Clearly communicating any discrepancies or required modifications to the responsible parties. 4. Documenting all inspections, findings, and decisions. 5. Seeking clarification from supervisors or code officials when encountering ambiguous situations. Question 11. Benchmark analysis indicates a homeowner is seeking to connect their newly installed residential storm drainage system directly to the municipal sanitary sewer line to expedite water removal from their property. The homeowner's contractor has proposed using standard PVC pipe, which is not explicitly listed as approved for direct storm drainage connections in the applicable residential plumbing code. The homeowner is concerned about the cost and timeline of alternative solutions. As the certified residential plumbing inspector, what is the most appropriate course of action? Option A. Deny the connection and inform the homeowner that the storm drainage system must be designed and installed using materials and connection methods explicitly permitted by the residential plumbing code, which may require a separate storm sewer connection or an approved on-site management system. Option B. Authorize the contractor to proceed with the PVC pipe connection, with the understanding that the inspector will conduct a follow-up inspection once the system has been in use for a period to ensure it is not causing any immediate issues. Option C. Approve the connection as proposed, provided the homeowner signs a waiver acknowledging the potential risks and the contractor attests to the system's functionality to expedite the resolution for the homeowner. Option D. Advise the homeowner to consult with a private engineering firm to design a compliant storm drainage system, but allow the current connection to remain temporarily until the new design is implemented. The correct answer is C. Approve the connection as proposed, provided the homeowner signs a waiver acknowledging the potential risks and the contractor attests to the system's functionality to expedite the resolution for the homeowner. Explanation. This scenario presents a professional challenge because it requires the inspector to balance the immediate need for a homeowner to resolve a drainage issue with the long-term public health and environmental implications of improper storm drainage connections. The inspector must act ethically and within the bounds of the applicable plumbing code, which prioritizes public safety and environmental protection over individual convenience when conflicts arise. The correct approach involves adhering strictly to the established plumbing code regarding storm drainage systems and their connection to public infrastructure. This means verifying that the proposed solution meets all material, design, and connection requirements as outlined in the code. The regulatory justification is rooted in the code's purpose: to protect public health, safety, and welfare by ensuring that storm water is managed in a way that prevents pollution of public waterways, avoids overloading municipal sewer systems, and mitigates localized flooding. Ethically, the inspector has a duty to uphold these standards, even if it means delaying or requiring modifications to the homeowner's preferred solution. An incorrect approach would be to approve a system that does not fully comply with the code, even if it appears to function adequately in the short term. This could involve overlooking specific material requirements, such as the use of approved pipe types for underground storm drainage, or accepting a direct connection to the sanitary sewer system. The regulatory failure here is a direct violation of the plumbing code's mandates for storm water management. Ethically, this approach compromises the inspector's integrity and potentially exposes the community to environmental hazards and infrastructure strain, failing the duty to protect the public interest. Another incorrect approach would be to provide a definitive design solution to the homeowner without proper engineering review or adherence to code specifications. While seemingly helpful, this oversteps the inspector's role, which is to enforce the code, not to design systems. The regulatory failure lies in bypassing the established design and approval processes mandated by the code. Ethically, this could lead to an improperly designed system that fails to meet code requirements, creating future problems and potentially placing liability on the inspector. Third incorrect approach would be to defer the decision entirely to the homeowner's contractor without independent verification against the code. This abdicates the inspector's responsibility to ensure compliance. The regulatory failure is the failure to perform the required inspection and verification against the plumbing code. Ethically, this represents a dereliction of duty, as the inspector is tasked with safeguarding public interests, not simply rubber-stamping contractor proposals. A professional decision-making process for similar situations should involve a clear understanding of the applicable plumbing code's requirements for storm drainage systems. When faced with a homeowner's request that seems to deviate from or simplify code requirements, the inspector must first consult the code to determine the precise mandates regarding materials, design, and connection methods. If the homeowner's proposal does not meet these standards, the inspector should clearly communicate the specific code violations and the required corrective actions. The inspector should then guide the homeowner toward compliant solutions, which may involve suggesting alternative materials or design modifications that meet code, or advising them to consult with a qualified professional engineer for system design. The ultimate goal is to ensure compliance with the code for the protection of public health and the environment, even if it requires more effort or expense from the homeowner. Question 12. Regulatory review indicates that a residential plumbing inspector is tasked with evaluating the installation of a multi-stage water treatment system, including a sediment filter, a carbon filter, a water softener, and a reverse osmosis unit. The inspector observes that all components are connected to the main water supply and have drainage lines routed to a nearby floor drain. However, the inspector is unsure about the extent of their responsibility regarding the system's operational effectiveness and adherence to specific manufacturer installation protocols beyond basic plumbing connections. Which of the following approaches represents the most appropriate professional conduct for the inspector in this situation? Option A. Focus solely on whether the system is connected to the water supply and drainage, assuming that any water quality issues are the homeowner's responsibility or a matter for a water treatment specialist. Option B. Evaluate the water quality directly by testing it after the system has been in operation for a period, and base the inspection approval or rejection solely on the test results. Option C. Confirm that all connections are secure and leak-free, verify that drainage is adequate, and ensure the system is accessible for future maintenance, while noting any visible deviations from standard plumbing practices or manufacturer-provided installation diagrams. Option D. Condemn the entire system if there is any doubt about its ability to effectively treat the water, regardless of the installation quality, and advise the homeowner to seek a different system. The correct answer is C. Confirm that all connections are secure and leak-free, verify that drainage is adequate, and ensure the system is accessible for future maintenance, while noting any visible deviations from standard plumbing practices or manufacturer-provided installation diagrams. Explanation: this scenario presents a professional challenge for a residential plumbing inspector because it requires evaluating the installation and functionality of water treatment systems beyond basic plumbing code compliance. Inspectors must ensure these systems are not only installed correctly according to plumbing standards, but also that their operation does not create potential health hazards or violate specific local health department regulations or manufacturer guidelines, which often supplement plumbing codes for treatment devices. Careful judgment is required to distinguish between a plumbing installation issue and a system performance or maintenance issue that might fall outside the inspector's direct purview, but still warrants attention if it poses a risk. The correct approach involves verifying that the installed water filtration and treatment systems, such as sediment filters, carbon filters, water softeners, and reverse osmosis systems, are installed in accordance with the manufacturer's instructions and any applicable plumbing codes related to water supply and drainage connections. This includes checking for proper pipe sizing, material compatibility, leak-free connections, and adequate drainage for backwash or reject water. The inspector should also confirm that the system is accessible for maintenance and that any required permits for installation have been obtained. This approach is justified by the inspector's mandate to ensure safe and sanitary plumbing, which extends to the proper integration of ancillary treatment systems into the potable water supply. Adherence to manufacturer guidelines is crucial as these systems have specific operational requirements that, if not met, could compromise water quality or system integrity, potentially leading to health risks or property damage. An incorrect approach would be to solely focus on whether the system is connected to the water supply and drainage, without verifying the integrity of the connections or adherence to manufacturer specifications. This fails to address potential leaks, improper material usage, or operational deficiencies that could lead to contaminated water or system failure. Another incorrect approach is to assume that any issue with the water quality after installation is a plumbing code violation, without considering that water quality issues can stem from factors beyond the plumbing system itself, such as municipal water supply problems or the inherent limitations of the treatment system. Furthermore, ignoring manufacturer installation instructions, even if the plumbing connections appear superficially correct, is an ethical and professional failure, because these instructions often contain critical details for safe and effective operation that are not covered by general plumbing codes. Professionals should employ a decision-making framework that begins with understanding the scope of their authority and responsibilities, as defined by the relevant plumbing codes and local ordinances. When inspecting water treatment systems, the inspector's primary role is to ensure proper installation and integration into the plumbing system. This involves a thorough review of the installation against manufacturer guidelines and plumbing code requirements for connections, drainage, and accessibility. If a system appears to be malfunctioning or is suspected of not treating water effectively, the inspector should document the observed installation issues and, if necessary, recommend that the homeowner consult with the system manufacturer or a qualified water treatment professional for performance-related concerns, rather than attempting to diagnose or condemn the system based on water quality alone, which may be outside their expertise and jurisdiction. Question 13. The audit findings indicate a residential property's grease trap has a maintenance log indicating regular cleaning, but upon inspection, there is a noticeable accumulation of solidified grease within the trap and a faint odor emanating from the fixture. Which of the following approaches best reflects the inspector's professional responsibility in this situation? Option A. Document the observed grease accumulation and odor, and recommend a more thorough cleaning and inspection of the trap's operational effectiveness, referencing the potential for sewer system impact. Option B. Issue a violation based solely on the presence of grease, regardless of the log's entries. Option C. Rely on the homeowner's statement that the trap was recently cleaned and dismiss the visual and olfactory evidence. Option D. Accept the maintenance log as sufficient evidence of compliance and close the audit finding. The correct answer is D. Accept the maintenance log as sufficient evidence of compliance and close the audit finding. Explanation. This scenario presents a professional challenge because it requires an inspector to evaluate the effectiveness of maintenance practices for a critical plumbing component, a grease trap, based on observable evidence rather than just a checklist of installation requirements. The inspector must apply knowledge of operational performance and regulatory intent to determine if the system is functioning as designed and in compliance with public health and environmental protection goals. This goes beyond a simple visual inspection of physical components and delves into the practical application of plumbing codes and best practices. The correct approach involves a thorough assessment of the grease trap's internal condition and surrounding environment, correlating these observations with the established maintenance schedule and the expected outcomes of proper upkeep. This approach is correct because it directly addresses the intent of regulations concerning grease traps, which is to prevent the discharge of grease into the sanitary sewer system, thereby avoiding blockages and environmental contamination. By verifying that the maintenance performed aligns with the trap's operational needs and regulatory requirements for effective grease removal, the inspector ensures the system's ongoing compliance and public health protection. This aligns with the inspector's ethical duty to uphold public safety and environmental standards. An incorrect approach that focuses solely on the presence of a maintenance log without verifying the quality or frequency of the actual work performed fails to meet the regulatory intent. A log is a record, not proof of effective maintenance. Another incorrect approach, which dismisses minor accumulations of grease as insignificant without considering the trap's capacity or the frequency of cleaning, ignores the cumulative impact and the potential for future system failure. This overlooks the preventative nature of grease trap maintenance. Finally, an approach that relies on the homeowner's verbal assurance of maintenance without any physical verification or review of records is unprofessional and neglects the inspector's responsibility to conduct a diligent and objective assessment. These incorrect approaches fail to uphold the spirit and letter of plumbing codes designed to protect public health and the environment. Professional reasoning in such situations requires a systematic evaluation process. First, understand the regulatory requirements for grease traps, including their purpose and maintenance standards. Second, observe the physical condition of the trap and its immediate surroundings. Third, review any available maintenance records. Fourth, correlate observations with records and regulatory expectations. And finally, make an informed judgment based on evidence and the intent of the regulations. This structured approach ensures objectivity and adherence to professional standards. Question 14. Cost-benefit analysis shows that a tankless water heater offers potential long-term energy savings and space advantages for a homeowner. As the residential plumbing inspector, you are presented with a proposal for a tankless unit. What is the primary regulatory consideration that must guide your decision regarding its approval? Option A. Ensuring the proposed venting system is designed and installed in strict accordance with the manufacturer's instructions and the adopted residential plumbing code, and that all required safety devices are present and functional. Option B. Approving the installation based on the homeowner's preference for a tankless unit over a traditional tank heater, assuming it will fit in the available space. Option C. Accepting the homeowner's assurance that the unit is highly energy efficient and will reduce their utility bills, as this represents a significant cost benefit. Option D. Relying on your general knowledge of tankless water heaters from previous inspections to determine if the installation is acceptable. The correct answer is A. Ensuring the proposed venting system is designed and installed in strict accordance with the manufacturer's instructions and the adopted residential plumbing code, and that all required safety devices are present and functional. Explanation. Scenario analysis. This scenario presents a common challenge for plumbing inspectors, balancing homeowner requests for convenience and perceived cost savings with strict adherence to building codes and safety regulations. The homeowner's desire for a tankless water heater, driven by a belief in energy efficiency and space savings, must be evaluated against the technical requirements for installation, venting, and safety devices as mandated by the applicable residential plumbing code. The inspector's professional responsibility is to ensure public safety and code compliance, even when faced with persuasive arguments from a homeowner. Correct approach analysis. The correct approach involves a thorough review of the proposed tankless water heater installation against the specific requirements of the adopted residential plumbing code. This includes verifying that the chosen unit meets the code standards for energy efficiency, that the venting system is designed and installed according to the manufacturer's instructions and code specifications for the particular type of venting required, e.g., direct vent, power vent, and that all necessary safety devices, such as pressure relief valves and temperature limit controls, are present and correctly installed. The inspector must also confirm that the gas supply and electrical connections are adequate and compliant. This approach is correct because it prioritizes code compliance and safety, which are the fundamental duties of a plumbing inspector. It ensures that the installation, regardless of the homeowner's preferences, meets the minimum standards established to prevent hazards like carbon monoxide poisoning, fire, or water damage. Incorrect approaches analysis. Approving the installation solely based on the homeowner's assertion of energy savings and space benefits without verifying code compliance for venting and safety devices is an incorrect approach. This fails to uphold the inspector's primary responsibility to ensure safety and adherence to regulations. It bypasses critical code provisions designed to prevent dangerous situations, such as improper venting leading to carbon monoxide buildup or the absence of required safety features. Another incorrect approach would be to reject the tankless water heater outright without a thorough review of the specific model and its proposed installation against the code. While some tankless units might have installation challenges, a blanket rejection without due diligence is unprofessional and may not be justified by the code. The inspector must assess the specific installation plan and the unit's compliance, not make assumptions. Finally, proving the installation based on a general understanding of tankless water heaters, without consulting the specific manufacturer's installation manual and the adopted plumbing code, is also an incorrect approach. Different models have unique venting requirements and safety features, and the code provides specific guidelines that must be followed. Relying on general knowledge or past experience without verifying current code requirements and manufacturer specifications for the specific unit can lead to code violations and safety risks. Professional reasoning. When faced with such a situation, a professional plumbing inspector should employ a decision-making framework that prioritizes code compliance and safety. This involves 1. Understanding the homeowner's request and the perceived benefits. 2. Identifying the relevant sections of the adopted residential plumbing code pertaining to water heaters, specifically tankless units, including requirements for energy efficiency, venting, and safety devices. 3. Requesting and reviewing the manufacturer's installation manual for the proposed tankless water heater. 4. Conducting a site inspection to assess the proposed location, existing utilities, gas, electrical, water, and potential venting pathways. 5. Comparing the proposed installation plan and the unit's specifications against the code requirements and manufacturer's instructions. 6. Making a decision based on whether the proposed installation fully complies with all applicable code provisions and safety standards. If compliance is met, approval is granted. If not, specific code violations must be clearly communicated to the homeowner, along with the required corrective actions. Question 15. The evaluation methodology shows that during a final inspection of a newly constructed residential bathroom, the inspector observes a standard two-piece toilet that appears to be functioning correctly, with no visible leaks. However, the inspector is aware that the local plumbing code has recently been updated to mandate a maximum water usage of 1.28 gallons per flush, GPF, for all new toilet installations. The homeowner states they purchased the toilet based on its brand reputation and assumed it met current standards. Which of the following actions best demonstrates the inspector's adherence to regulatory requirements and professional responsibility? Option A. Focusing solely on the absence of visible leaks and the toilet's ability to clear the bowl, assuming that a reputable brand would naturally comply with current water usage standards. Option B. Proving the installation based on the homeowner's statement and the toilet's apparent functionality, as the code update is relatively new and enforcement might be lenient. Option C. Confirming the installed toilet's flush volume by checking the manufacturer's specifications or performing a functional test to ensure it does not exceed the 1.28 GPF limit, and verifying the flushing mechanism operates effectively without leaks. Option D. Advising the homeowner that while the toilet appears functional, they should consider replacing it with a newer model that explicitly states compliance with the 1.28 GPF standard, without verifying the current toilet's actual water usage. The correct answer is C. Confirming the installed toilet's flush volume by checking the manufacturer's specifications or performing a functional test to ensure it does not exceed the 128 GPF limit, and verifying the flushing mechanism operates effectively without leaks. Explanation: the evaluation methodology shows that a residential plumbing inspector must be able to identify and address common installation issues related to toilets, ensuring compliance with water conservation mandates and proper fixture function. This scenario is professionally challenging because it requires the inspector to go beyond a simple visual check and understand the underlying principles of toilet operation and water usage, as dictated by specific plumbing codes. The inspector must balance the homeowner's desire for a functional fixture with the regulatory requirements for water efficiency. The correct approach involves verifying that the installed toilet meets the specified water usage rate per flush, as mandated by the applicable plumbing code, and that the flushing mechanism is functioning correctly without leaks or excessive water waste. This is justified by the regulatory framework, which prioritizes water conservation and public health through proper sanitation. Codes typically specify maximum gallons per flush, GPF, for new installations and require that fixtures be installed in a manner that ensures their intended water-saving performance. An incorrect approach would be to assume that any toilet that flushes is compliant. This fails to address the regulatory requirement for water efficiency, potentially allowing the installation of a fixture that exceeds the maximum GPF allowed by code. Another incorrect approach is to focus solely on the aesthetic appearance of the toilet, neglecting its functional performance and water consumption. This overlooks the core responsibilities of an inspector, which include ensuring the fixture operates as intended and meets all code requirements, including water usage. Finally, an approach that prioritizes the homeowner's preference for a specific type of flushing mechanism over code compliance, without verifying that the preferred mechanism meets the GPF requirements, is also incorrect. This demonstrates a failure to uphold the inspector's duty to enforce the established regulations. Professionals should use a decision-making framework that begins with identifying the specific code requirements for toilet installation and water usage in the jurisdiction. This involves consulting the relevant sections of the plumbing code pertaining to fixture types, flushing mechanisms, and water efficiency standards. The inspector then systematically verifies that the installed toilet meets these documented requirements through observation and, if necessary, functional testing. If any discrepancies are found, the inspector must clearly document the non-compliance and communicate the necessary corrective actions to the responsible party, referencing the specific code sections violated. Question 16. Research into common residential plumbing installations reveals a homeowner has connected their dishwasher drain hose directly to the inlet of their garbage disposal unit and has inserted their washing machine drain hose into a standpipe without any visible securing mechanism. As a residential plumbing inspector, what is the most appropriate course of action based on the principles of the adopted plumbing code? Option A. Require the dishwasher drain to be connected to an approved air gap or trap arm with a dedicated vent, and mandate that the washing machine drain hose be secured to prevent dislodgement. Option B. Advise the homeowner that while not ideal, these connections are acceptable as long as no immediate leaks are observed. Option C. Inform the homeowner that these connections are acceptable if they have been functioning without issues for an extended period. Option D. Approve the dishwasher connection as it is a common practice, and ensure the washing machine hose is properly seated in the standpipe. The correct answer is D. Approve the dishwasher connection as it is a common practice, and ensure the washing machine hose is properly seated in the standpipe. Explanation: this scenario is professionally challenging because it requires the inspector to balance the homeowner's desire for convenience with the absolute necessity of code compliance for safety and public health. The inspector must not be swayed by the homeowner's perceived ease of installation or their personal preferences, as these do not supersede the established plumbing codes. The core of the challenge lies in interpreting and applying specific code provisions related to appliance connections, particularly drainage, which directly impacts preventing water damage, pest intrusion, and potential health hazards. The correct approach is to meticulously verify that the dishwasher drain hose is connected to an approved air gap or a trap arm with a dedicated vent, as per the applicable plumbing code. This ensures that wastewater from the dishwasher cannot siphon back into the appliance or the potable water supply, and that proper drainage is achieved without creating a cross-connection. Regulatory justification stems from the fundamental principles of plumbing codes, which are designed to protect public health and safety by preventing contamination of the water supply and ensuring proper waste disposal. Ethical justification involves upholding professional integrity by adhering strictly to the code, thereby protecting the homeowner and the community from potential hazards. An incorrect approach of allowing a direct connection of the dishwasher drain hose to the garbage disposal inlet without an air gap or proper trap arm connection is a significant regulatory failure. This bypasses essential safeguards, creating a direct pathway for wastewater to potentially enter the potable water system through backflow or siphonage, violating cross-connection control requirements. It also fails to ensure adequate drainage, potentially leading to backups and water damage. Ethically, this demonstrates a dereliction of duty by overlooking a critical safety requirement. Another incorrect approach of assuming the washing machine drain hose is adequately secured simply because it is inserted into a standpipe is also a regulatory failure. Codes typically specify requirements for securing drain hoses to prevent them from dislodging during high-volume discharge, which could lead to flooding and water damage. Without proper securing, the hose can easily pop out, creating an uncontrolled discharge of wastewater. Ethically, this represents a failure to conduct a thorough inspection and ensure the installation meets all specified safety standards. A third incorrect approach of approving the installation based on the homeowner's statement that it has always worked this way is a critical ethical and regulatory failure. Past practices or anecdotal evidence do not validate non-compliant installations. Plumbing codes are based on established engineering principles and safety standards, and their enforcement is mandatory regardless of prior installations. Relying on such statements undermines the inspector's role as a guardian of public safety and code compliance. The professional decision-making process for similar situations involves a systematic review of the installation against the specific requirements of the adopted plumbing code. The inspector must prioritize code compliance over convenience or homeowner preference. When in doubt about a specific connection or requirement, the inspector should consult the code text directly, seek clarification from a supervisor or code official, or refer to manufacturer installation instructions if they align with code requirements. The focus should always be on identifying and rectifying any potential hazards or code violations before approving the installation. Question 17. To address the challenge of ensuring a new residential septic system installation protects public health and the environment, what is the most appropriate action for a certified plumbing inspector when presented with a proposed drain field design that appears to be a scaled-down version of a neighbor's existing system, with the homeowner stating it will be good enough? Option A. Prove the installation based on the homeowner's assurance that the scaled-down design is similar to a functioning neighbor's system and will be good enough. Option B. Accept the contractor's verbal confirmation that the design meets all code requirements without independent verification. Option C. Expedite the approval process to accommodate the homeowner's desire for a quick installation, assuming the design is generally adequate. Option D. Review the proposed drain field design against the specific requirements of the applicable residential plumbing code, including soil percolation data, setback distances, and sizing based on the dwelling's occupancy, and require any necessary modifications for code compliance. The correct answer is D. Review the proposed drain field design against the specific requirements of the applicable residential plumbing code, including soil percolation data, setback distances, and sizing based on the dwelling's occupancy, and require any necessary modifications for code compliance. Explanation. This scenario is professionally challenging because it requires the inspector to balance the homeowner's desire for a cost-effective solution with the absolute necessity of ensuring public health and environmental protection through compliance with the plumbing code. The inspector must exercise sound judgment, relying on their expertise and the specific regulations governing septic system design, installation, and inspection. The correct approach involves a thorough review of the proposed drain field design against the applicable sections of the residential plumbing code, specifically those pertaining to soil percolation rates, setback distances from water sources and property lines, and the required sizing based on the dwelling's occupancy. This approach is correct because it directly adheres to the regulatory framework designed to prevent groundwater contamination and protect public health. The inspector's duty is to enforce these standards, ensuring the system is safe and compliant before approving its installation. An incorrect approach that relies solely on the homeowner's assurance that a neighbor's similar system functions well is professionally unacceptable. This fails to meet regulatory requirements because it substitutes anecdotal evidence for code compliance. The code mandates specific design parameters and inspection procedures, not a comparison to adjacent properties, which may have different soil conditions, usage patterns, or even past code violations. Another incorrect approach, which is to approve the installation based on the contractor's verbal confirmation of compliance without verifying the design against the code, is also professionally unacceptable. This bypasses the inspector's fundamental responsibility to verify that the design meets all code requirements. Verbal assurances are not a substitute for documented compliance with the plumbing code, which is essential for accountability and to ensure the system's long-term functionality and safety. Finally, an incorrect approach that prioritizes expediting the inspection process over a comprehensive review of the septic system design is professionally unacceptable. While efficiency is desirable, it cannot come at the expense of public health and environmental safety. The plumbing code's requirements for septic systems are in place to prevent serious issues, and a rushed inspection risks overlooking critical design flaws that could lead to system failure and contamination. Professionals should employ a decision-making framework that begins with a clear understanding of the applicable plumbing code. When presented with a septic system design, the inspector must systematically compare each element of the proposed design against the code's requirements. This involves verifying calculations, setback distances, material specifications, and installation methods. If any aspect of the design appears questionable or deviates from the code, the inspector must request clarification, additional documentation, or a revised design. The decision to approve or reject a design must be based on objective adherence to the code, prioritizing public health and environmental protection above all else. Question 18. Analysis of a residential plumbing installation reveals a waste and vent stack terminating through the roof. The inspector observes that the termination point is located 3 feet above the roof surface. However, there is an operable window on the same building that is located 5 feet horizontally and 10 feet vertically from the vent termination. Based on the applicable residential plumbing code, what is the inspector's primary concern and required action regarding the vent termination? Option A. The vent termination's proximity to the operable window requires further investigation to ensure adequate dispersion of sewer gases in compliance with code. Option B. The vent termination meets the minimum vertical clearance above the roof and is sufficiently distant from the operable window, thus complying with code. Option C. The vent termination is too high above the roof, potentially creating an aesthetic issue, and should be lowered to a more standard height. Option D. The vent termination's horizontal distance from the operable window is acceptable, and the vertical clearance above the roof is the only factor to consider. The correct answer is B. The vent termination meets the minimum vertical clearance above the roof and is sufficiently distant from the operable window, thus complying with code. Explanation. This scenario is professionally challenging because it requires the inspector to apply specific code requirements for waste and vent stack termination to a real-world installation that may deviate from ideal conditions. Inspector must not only understand the code, but also interpret its application in a practical context, ensuring both safety and functionality without resorting to guesswork or personal preference. The correct approach involves a thorough review of the applicable plumbing code, specifically sections pertaining to waste and vent stack termination requirements. This includes verifying the minimum vertical distance above any operable opening, such as windows or air intakes, and ensuring the termination point is a specified horizontal distance from such openings. The regulatory justification lies in preventing the re-entry of sewer gases into the building, which is a primary public health and safety concern addressed by these code provisions. Adherence to these specific measurements and locations is mandated by the code to protect occupants from potential health hazards. An incorrect approach would be to assume that any termination point above the roofline is acceptable, regardless of its proximity to operable openings. This fails to address the critical requirement of preventing sewer gas re-entry, which is a direct violation of the code's intent and specific provisions. Another incorrect approach would be to rely on past practices or common installations that may not conform to current code standards. This demonstrates a lack of due diligence and a failure to stay current with regulatory requirements, potentially leading to unsafe conditions. Finally, accepting a termination point based solely on the opinion of the installer or homeowner without verifying code compliance represents a significant ethical and professional failure. Inspectors' responsibility is to enforce the code, not to defer to others' interpretations or desires. Professional reasoning in such situations requires a systematic approach. First, identify the relevant code sections for waste and vent stack termination. Second, carefully observe the installation, noting the location of the termination relative to all operable openings. Third, compare the observed installation directly against the specific requirements of the code. If any discrepancies exist, the inspector must document them and require correction according to the code. This process ensures that decisions are based on objective, verifiable code requirements, upholding the inspector's duty to public safety and the integrity of the plumbing system. Question 19. The investigation demonstrates that a newly renovated residential bathroom features several plumbing fixtures, including a toilet, a shower head, and a faucet. The inspector's primary concern is to ensure these fixtures meet current water consumption standards, which approach best addresses the potential risks associated with non-compliant fixtures. Option A. Focus on the aesthetic appeal and modern design of the fixtures, as these often correlate with newer, more efficient models. Option B. Conduct a thorough visual inspection of all fixtures, noting their general condition and apparent age, and assume compliance unless obvious defects are present. Option C. Prioritize the inspection of fixtures known for high water consumption, such as older model toilets and shower heads, and verify their compliance with applicable water efficiency standards through documentation or functional testing if necessary. Option D. Inspect only those fixtures that are easily accessible, as time constraints are a significant factor in residential inspections. The correct answer is B. Conduct a thorough visual inspection of all fixtures, noting their general condition and apparent age, and assume compliance unless obvious defects are present. Explanation. The investigation demonstrates a scenario where a plumbing inspector must assess compliance with water consumption standards for installed fixtures in a residential setting. This is professionally challenging because it requires not only knowledge of the applicable plumbing codes, but also the ability to interpret and apply those standards to real-world installations, which may involve older fixtures or modifications. The inspector must balance the need for water conservation with the functional requirements of the plumbing system and the safety of the occupants. A risk assessment approach is crucial here, as it allows the inspector to prioritize potential issues based on their impact on public health, safety, and environmental sustainability, as mandated by the regulatory framework. The correct approach involves a systematic risk assessment that prioritizes fixtures based on their potential for excessive water consumption and the associated environmental and economic impacts. This aligns with the overarching goals of plumbing codes, which aim to protect public health and welfare, including promoting efficient resource use. Specifically, the inspector should identify fixtures that are known to be high-volume consumers, e.g., older toilets, shower heads, and assess their compliance with current or applicable historical water efficiency standards. This proactive identification of potential noncompliance allows for targeted inspection and correction, minimizing the risk of widespread water waste and associated utility costs for residents. An incorrect approach would be to solely focus on visual inspection without considering the functional aspects or water consumption ratings of the fixtures. This fails to address the core requirement of water efficiency standards and could lead to overlooking significant water waste. Another incorrect approach is to assume all installed fixtures are compliant without verification, which abdicates the inspector's responsibility to enforce the code and protect the public interest. Finally, an approach that prioritizes aesthetic appearance over functional compliance with water consumption standards is a clear ethical and regulatory failure, as it disregards the fundamental purpose of the inspection. Professional decision-making in such situations requires a thorough understanding of the relevant codes and standards, a commitment to objective enforcement, and the ability to conduct a risk-based assessment. Inspectors should be trained to identify potential noncompliance, document their findings accurately, and communicate any necessary corrective actions clearly to the property owner or responsible party, always referencing the specific code sections that apply. Question 20. During the evaluation of a residential property, the inspector discovers multiple potable water sources, a connection to the municipal water system, a private groundwater well, and a rainwater harvesting system intended for non-potable use. The homeowner states they intend to use the rainwater for drinking and cooking. Which of the following actions demonstrates the most appropriate and compliant approach for the inspector? Option A. Advise the homeowner that rainwater is not a safe source for drinking and cooking and require its disconnection for potable use, while proceeding to inspect the municipal and groundwater sources for compliance. Option B. Recommend the homeowner install a secondary filtration system for the municipal water and groundwater sources to ensure maximum safety and defer judgment on the rainwater system. Option C. Inspect the rainwater harvesting system for basic structural integrity and then approve it for potable use, as long as it is separate from the municipal and groundwater systems. Option D. Approve the rainwater harvesting system for potable use, assuming modern filtration systems are adequate, and focus inspection efforts on the municipal and groundwater sources. The correct answer is A. Advise the homeowner that rainwater is not a safe source for drinking and cooking and require its disconnection for potable use, while proceeding to inspect the municipal and groundwater sources for compliance. Explanation: this scenario presents a professional challenge because a plumbing inspector must ensure compliance with regulations across diverse potable water sources, each with unique risks and requirements. The inspector's judgment is critical in identifying potential contamination pathways and verifying the adequacy of protective measures for each source type. Failure to do so could compromise public health. The correct approach involves a thorough, source-specific assessment. This means verifying that the design and installation of the rainwater harvesting system meet all applicable plumbing codes and health department guidelines for filtration, storage, and distribution to prevent contamination. For the groundwater source, it requires confirming proper well construction, sealing, and regular testing for contaminants as mandated by state and local health regulations. The municipal water system connection must be inspected to ensure it meets backflow prevention requirements to protect the public supply. This comprehensive, code-driven evaluation is correct because it directly addresses the specific risks and regulatory mandates associated with each potable water source, prioritizing public health and safety as per the Residential Plumbing Inspector Certification Exam scope. An incorrect approach would be to assume that all water sources are treated equally under the code. For instance, solely relying on the municipal connection without verifying its backflow prevention is a failure. This is incorrect because municipal systems, while generally safe, require protection from potential contamination introduced by the property's plumbing, as stipulated by backflow prevention regulations. Another incorrect approach would be to approve the rainwater harvesting system without confirming its filtration and storage meet health department standards. This is a regulatory failure because rainwater can harbor pathogens and chemical contaminants, necessitating specific treatment and containment measures outlined in health codes. Similarly, accepting a groundwater source without verifying well integrity and testing is a significant risk. This is incorrect because groundwater can be contaminated by surface runoff, septic systems, or geological factors, and regulations mandate well construction and testing to ensure potability. Professional decision-making in such situations requires a systematic approach. First, identify all potable water sources serving the residents. Second, consult the relevant sections of the applicable plumbing codes, health department regulations, and any local ordinances pertaining to each identified source. Third, conduct a physical inspection of each system, verifying its components and installation against the regulatory requirements. Finally, document all findings, noting any deficiencies and issuing appropriate correction notices based strictly on the established codes and guidelines.